In this next example, we start to make the cross-section a little bit more complicated. We started off with a pipe that was axisymmetric, and now we have a square, hollow structural steel shape. So it is symmetric in two different axes and identical too, because it's in a square, 2 by 2 inches across the face and then a 1/4 inch wall thickness. You could calculate the area and the second moment of area, but we've already been given some of those geometric properties. If the area equals 1.51 square inches and the radius side gyration is 0.806 and our length is 72 inches. Now our basic model is P sub E equal pi squared EI over L squared, and we don't see R in that expression, but that's where you're supposed to remember that the radius side gyration is equal to the square root of I over A. So that means, of course, that I is equal to R squared times A. Now, if you want to go ahead and calculate those all out and put it in for I, you could go ahead and do that. I'm not going to. I'm just going to directly substitute that right up there. I'm going to do it all at once. Right, so P sub E then equals pi squared E I over L squared. That means pi squared E times R squared times A over L squared. Notice, before we put in numbers, if we wanted a critical stress, we could take that area and take it over here and take P sub E divided by A, and that would give us the critical buckling stress, or Euler stress. So expressed in terms of stress units as opposed to, of course, in force units. All right, but we want the total force, so let's go ahead and work this all out. Pi squared, it's steel, right? HSS tells us that it's steel. 29,000 kips per square inch times our R value, which is 0.806 inches, and that whole thing has to be squared. And then times the area, 1.51 inches squared. Right, so again, we'll have units in the numerator that will work out to be kip inch squared total. And then we'll divide by the length, which is already in inches, so 72 inches. And that's also a squared value. So let's see what we get on this one. We'll have pi squared times 29,000 times 0.806, that has to get squared, times 1.51, the cross-sectional area, and divide by 72 inches squared. And we have a smaller value than we had before, but still quite significant. That's 54,000 kips. Not sure I'm going to be too focused on the 0.106 there, or 0.16, because everything about buckling is very imperfection sensitive, and so I would not get too precise in my final answer on that. So that's our second example, and we'll get ready for the third.